Good afternoon and welcome everybody. My name is Jennifer Gottwald. I'm a Director of Licensing at WARF, and this is another iteration of our Wisconsin CleanTech Network Forum. WARF has been sponsoring or putting on this forum for a couple of years now, taking it over from some other groups, and it's a chance for people involved in sustainability and clean tech within the state of Wisconsin to come together and share their thoughts. This is the first one we are doing virtually, so want to let everybody know this will be recorded and we'll have a link available, so if you miss some points or want to share it with friends, you'll be able to do that afterwards. Really excited about our topic today. We're going to be talking about advancing Wisconsin's green manufacturing economy. We're going to have a couple of speakers from UW-Eau Claire, and we'll also have some of their collaborators from other UW system schools who will be joining in on the discussion. This resulted from a project, a collaboration project between UW-Oshkosh, UW-Eau Claire, and UW-Milwaukee that was funded by the Thompson Center for Public Leadership that's housed at UW-Madison. So a great idea of the collaborations between different UW system schools in a really good way. We're going to have two speakers who are going to speak for about 20 to 30 minutes, and we'll be having questions and good discussion afterwards. So please put your questions in the Q&A and we'll get to those at the end of the speaking part. Our two speakers today are going to be Dr. Matt Jewell, who's an Associate Professor of Material Sciences and Engineering at UW-Eau Claire, and Dr. Thomas Kemp, who's the chair and professor in the economics department at UW-Eau Claire. So with that, I'm going to turn it over to Matt and Tom.
Okay, well, it's great to be here. Thanks for having us on. This was an exciting project, and we're happy to work on it. I'm Dr. Thomas Kemp, professor and chair of Department of Economics at University of Wisconsin-Eau Claire. I'm going to lead off the presentation here with the first few slides talking about the economics portion of this work, and then very quickly we'll move into the other areas of the report, and Dr. Matt Jewell will lead that part. So this was a pretty complicated problem. What we're trying to figure out, first of all, is really what's Wisconsin's capacity to engage in either the production of greener energy or green energy supply chains. So as we see in this first slide, the state of Wisconsin remains relatively underdeveloped in terms of green energy and green energy supply chain when compared to other states in the upper Midwest, such as Iowa or Minnesota. And that puts us in a place where there's an opportunity. If you hit the next slide quick. So this is really an opportunity because the future is very likely greener technologies. Most estimates show that particularly solar and wind power are how we're going to generate energy 20, 30 years from now. And so enabling that transition from existing technologies, existing means of energy production to the likely future of energy production is an important question. How can Wisconsin really leverage itself economically throughout that transition? So that was the question. And that's a bit of a difficult thing to discover because most of the economic data we have doesn't give, firm X produces Y output. No, it's firm X produces $50,000 of economic output. So what we were trying to do is to actually figure out what firms would be best positioned to maybe move incrementally towards greener energy production. And we focused our attention really on the manufacturing sector because here in Wisconsin, the manufacturing sector is quite strong. Prior to the COVID-19 situation, I think it's beyond a pandemic at this point, manufacturing in Wisconsin was at a 10-year high. Here on the graph on the slide, we see the sort of trajectory of Wisconsin manufacturing over the last 10 years. We can see that excluding the last couple of months of data, right? This is it's an upward trajectory, right? And in terms of jobs, it constitutes roughly 16% of the entire state. Now, when compared to the nation as a whole, that average is only 10%, right? So manufacturing is much more important in Wisconsin than it is in most other states across the union. And so it's an important part of the Wisconsin economy, and we're trying to understand how we can bring this sort of mighty force of Wisconsin manufacturing to bear upon green energy supply chain. So maybe we'll pop to the next slide. In terms of output, we're talking, over a $50 billion industry annually, manufacturing that is, right? And this amounts to 19, roughly 20% of the state total by value. Here we have the sort of trajectory of that. You see it's upward sloping, but fairly steady, right? And by value, that makes this the largest sector in the state, right? So Wisconsin manufacturing, despite reports to the contrary, right, is strong, remains strong, and indeed is if anything, getting somewhat larger. So we've got a lot of firms here across the state, thousands and thousands of firms across the state that are engaged in various aspects of manufacturing. And what we're trying to do is to find the specific firms within that very, very large haystack, if you will, of manufacturing firms that would be well placed to move us in this direction towards being able to more effectively capture these markets as they emerge. So of course, what are the forces that are moving us along this trajectory, right? Well, one is global climate change. And well, that's a very politically a hot topic, right? Most signs point that, that's the direction we're going to go. Of course, as COVID-19 pops up, right, it's created all kinds of supply chain issues, not just in this sector, but within several sectors as well. And so certainly this is going to lead to a rethinking of how global supply chains are organized. And so our study hopefully will allow us to think a little more effectively about how, as that reorganization occurs, we can become a larger part of it. And so when you take those ideas together, you have a lot of opportunity. Now, I don't want to go on too long here, so I'll start wrapping my section up. What we find, right, in uncovering these firms, and we covered about 200 firms that we think are good matches, and indeed, actually, firms have already been getting a hold of me, and I know others on this team that have worked on this project and saying, hey, how can we be a part of this? It's really exciting. We're finding out about more and more firms. But the thing that I really want to leave everybody with, or leave the listeners with, is the idea that as we move right towards green energy, if we think carefully about this and we think about how this is going to go, it doesn't necessarily mean that we lose jobs, or even that we necessarily gain jobs, right? But it does mean that we're going to change types of jobs we're doing, right? And so as we make that change in jobs we're doing, information is useful, information is important. How can we work with each other as businesses, academics, researchers, practitioners? How can we work together to make those transitions from the things we're doing now to the things that we will be doing as smooth as possible? And with that, I'll turn it over to Matt.
Great, thank you, Tom, and hello, everybody. Nice to be with you this afternoon, and thanks to WARF for the opportunity to talk through our project here. As Tom said, this project kind of started by trying to think about where are we in the state with manufacturing, and sort of what's the potential for transitioning more into some of these green energy areas. And I think kind of the nucleus for us was that we sort of just had this intuition that what, a lot of the traditional strengths we have in manufacturing, high precision machining, metallurgy, you can kind of, list kind of go on, metal forming. A lot of those things should be fairly applicable to different kind of clean energy or green energy technologies. And in fact, as Tom and his colleague Yan Lee found, there already are quite a few Wisconsin manufacturers participating in those areas. But we wanted to kind of quantify that a little more, and we wanted to, as a sort of engineering analysis part of this project, wanted to go through and kind of identify some specific opportunities. If companies wanted to get more involved into green energy production or supply chains for green energy products, what would that look like? What are kind of current challenges or current things that might be useful for them? So that's what I want to talk through. Just a couple slides of background. I just want to kind of give a little bit of an impetus for why we looked at the specific energy sectors that we did. So let me talk first about wind and solar. Those are pretty obvious ones, of course. Wind is something now of a mature industry. In Wisconsin, there's about 400 wind turbines across the state and about 700 megawatts of installed capacity. For comparison, that's sort of like one large coal-fired power plant when you get up to that 700, 800, 900 megawatt range. And I would say that actually in the last decade, or let's say from about 2010 to 2017, there actually was not a lot of growth in wind capacity in Wisconsin, but there has been some more recently now, and you see a picture here on the screen of the Quilt Block Wind Farm down in the southwest part of the state, which is a newer project. So there is some growth, but also the other thing we discovered that actually is a pretty sustainable industry is just the continued kind of replacement, repair, upgrade of different wind turbine components that are needed to keep the industry going. As technology develops, as blades get lighter and stronger and stiffer and larger, as gearboxes get more efficient, et cetera, there's actually a real impetus, real economic driver to be kind of constantly upgrading of various components, just because you get more power out of the same tower. So that made us interested in looking more into that, and actually wind, the sort of components of wind towers built out of, aligns pretty nicely with Wisconsin's traditional manufacturing capacity. Okay, solar, of course, is a very rapidly growing industry. I don't think I need to give significant background there. Prices for solar cells have just plunged over the last decade, to the point now where not only is it competitive with, let's say, a coal-fired power plant on a complete life cycle analysis, solar is also competitive economically just on an operating perspective, by which I mean it is cheaper to build and operate the solar field in many cases and amortize the cost of the construction. It's cheaper to do that than to operate existing coal-fired power plants. And so this has produced a huge shift now in the electric power industry. Many projects coming online. Most of the solar projects in Wisconsin existing are smaller, 1 to 5 kind of megawatts, but now much larger fields have been proposed. This Two Creeks Farm project that you see here is 150 megawatts, and there's projects up to 300 megawatts proposed. So we're going to very quickly, I think, get to a gigawatt of installed capacity in Wisconsin, and there's no real end in sight there. Okay, so obvious area for growth and one to look for. Okay, we also looked at 2 other sectors that are interesting for different reasons. Of course, lithium-ion batteries, very rapidly growing as well. Electric vehicles, portable devices, all of those things. Also, costs have come down very significantly in the last decade. Current costs on a sort of per kilowatt hour basis are still about twice what U.S. Department of Energy has put out as a spec. We'd like to get down to $80 per kilowatt hour as a target. But there's great opportunities here. This Safe Lithium Materials is a company in Wisconsin that's building graphite oxide anode materials for the lithium industry. And so we'll talk a little bit through some of the opportunities there. And then biogas, which is a little bit more of a niche opportunity maybe, but it's really well aligned, of course, with the agriculture sector in Wisconsin. So decomposition of manure and dry agricultural waste both have good opportunities for producing biogas, and so we'll talk through that a little bit as well. Okay, so those are the 4 sectors we're going to look at. I'm just sneaking one slide in here about nuclear fusion, which maybe doesn't quite seem to fit with the others. And we wrote about it in our proposal and said, we'd like to look at this too. And it's like, boy, isn't that a little bit out there? I mean, I have a little bit of experience in the nuclear fusion industry, and there's this joke among physicists that fusion is 30 years away and always will be, right? Is kind of what people say. But actually, the reality in the last decade has changed. There's a very large science reactor, the ITER reactor in France, that's going to be coming online, hopefully this decade. But then actually the real change in fusion is there are now several privately funded companies that are essentially building their own machines and have plausible paths to producing real power by fusion energy. So we decided for the sake of this report that probably the supply chains were not mature enough to really warrant inclusion or try to talk with manufacturers about getting involved in supply chains now. But I will say, you know, other industries like wind and solar, as those industries mature, the sort of profit margins on the supply chain start to come down. Whereas here in fusion, there's some very interesting things happening, some very interesting companies doing work, and there's some good partnerships to be had. So if someone is interested in talking further about that, we'd be happy to have that conversation offline. Okay, but we did decide not to include that in our report here. Okay, so then let me just kind of talk briefly. I'll just highlight a few of our findings and then some of our policy recommendations, and then we'll do some Q&A. So the first thing needs to be said is as soon as we sort of cracked this box open, we realized just kind of the enormity of what we had signed ourselves up for, that within each of these technology areas, within each of these sectors, we are talking about, you know, dozens of industries supplying components, literally hundreds of supply chains. There was just no way that we were going to somehow comprehensively list out every good opportunity for a Wisconsin manufacturer to integrate themselves into the supply chains. So what we try to do in the report is identify a few specific opportunities and sort of talk through them. And then as I'll describe at the end, we then sent this out to manufacturers and sort of said, you know, here are a few things that might be interesting. Why don't you give us a call and let's see if we can find something that works for you. So anyway, I'll just highlight a couple things here. So for wind, as I've already said, we found that in general, the sort of things that Wisconsin is good at from a traditional manufacturing point of view align really nicely with the things you have to build for a wind turbine. And I talked about the repair upgrade issue. Also, there are still pretty strong funding opportunities through things like small business grants. You know, sometimes as these technologies mature, federal agencies start to get a little bit less interested in funding them as aggressively. But we found there's still very strong SBIR support. And so for the right company, you know, that's something maybe a UW system school could partner with them with and develop some relationship there. So essentially what we did in the report is we just tried to identify a handful of kind of technology areas and then describe them for the manufacturer, talk about what the needs are, and then maybe where they could go for funding. So I'm just going to kind of pick one just for the sake of time here and talk you through it. So that you can see the bullet points here. If someone would like us to talk through one of these other ones, I'd be happy to do it. There's some very interesting issues here. But one kind of unique one that I didn't know a lot about before I got into this project is big area additive manufacturing. So basically what this is in order to make these enormous turbine blades, you have to make this composite material, which involves casting resin around some kind of glass or carbon fiber or other very stiff fiber material. And big area additive manufacturing is a way of 3D printing these enormous, sometimes 200-foot long or bigger molds, which then the turbine blades can be cast into and formed. Okay, so there's a lot of interesting little technology challenges associated with doing that. So what we try to do in the report is just describe the technology, describe sort of current needs or what needs to be improved, and then where could a company go maybe to find some more funding or follow up on that. And let me just kind of show you how that looks in the report. So we just tried to write kind of a relatively simple paragraph describing the technology using just kind of, you know, language that a wide variety of readers would maybe appreciate, be able to understand. And then kind of a paragraph on, so what do they need? And the goal here for those that are patient enough to kind of read through the report, the goal here would be that hopefully some of the specifications and the details in here would sort of perk their interest and say, hey, we do that, right? That's a thing that we're good at, and or maybe we could contribute something to it. So we tried to, the balance we tried to strike was to have kind of enough technical detail to sort of, you know, clue in the engineers and the folks reading the report that hey, maybe this is something we could think about, but not get too buried in some of the science and the engineering. Then we, as I say, tried to go through and find, for example, federal or other opportunities where if you say, hey, I've got an interesting idea for, you know, improving the tolerances of a big area additive manufacturing apparatus, so you can 3D print these molds more accurately. Then here are some places where the federal government is currently saying, hey, we maybe are interested in that. Obviously, these are mostly SBIRs. Not every company is eligible for SBIRs, but we try to go through on a case-by-case basis, opportunity by opportunity, and kind of highlight these to make that transition path a little bit easier for folks. Okay, so that's just one example from wind. Let's talk real generally about solar technology here a little bit. I think a main finding of ours is that the sort of key solar technology you think about, which is making the photovoltaic cell, which is going to do the light to electricity conversion, that is a mature, incredibly competitive industry, very large global manufacturers. Felt like very hard to sort of find a niche in there. So we didn't think from the point of view of trying to help existing Wisconsin manufacturers transition, we didn't feel like that was really the right thing to say, hey, why don't you try and get into manufacturing PV cells? So instead we tried to find a few interesting things sort of around the edges, if you like, sort of ancillary technologies that fit into the production of solar modules. And again, happy to talk through any of these at the conclusion. Let me just highlight one. So a bifacial solar module. This is an interesting technology where you have a set of solar cells here up on the roof of this bus stop, but both sides are generating electricity, both sides of the cell. So of course it's receiving light from the top, but there's also reflection off the ground, and it's also picking up light from that side. And there's so this can be a little more efficient, sort of on a per square foot or per square meter basis. You're collecting more energy than you normally would. And so interesting technology, bunch of little issues associated with that. But an important one here is how you encapsulate this glass cell that you need to kind of bond together. So a traditional encapsulant is this EVA, which is ethylene vinyl acetate. And that works for a lot of solar technologies, but in particular, this glass interface can be kind of susceptible to corrosion. And so EVA is not always the best choice. So sometimes this alternative material, TPO, which is thermoplastic polyolefin, that's used instead. And that's fine, but then that has sort of cost issues. And so the need then from the industry is we need to find some ways to bring down the cost of the TPO, or think of some different alternatives that could be an encapsulant instead. So just like in the case of the big area additive manufacturing, we just try to provide sort of enough technical details in the report for manufacturers to say, yeah, okay, I can think about some kind of epoxy system or something that I might be able to produce that could potentially be an alternative there, and let's go find a way to kind of try that out. Okay, I'm just going pretty rapidly through these here, so we don't kind of spend all afternoon. Lithium-ion batteries. This part of the project was spearheaded by Junjie Niu at UW-Milwaukee, and so I'll defer questions on it to him in the Q&A. But a number of interesting findings here. First is that there's still a lot of R&D to do. So obviously we are seeing electric vehicles, hybrid vehicles. Every single one of you has a cell phone or a tablet. So these batteries are absolutely everywhere. There's still a lot to be done in terms of increasing capacity, decreasing cost, improving reliability, improving recycling, all those sort of things. So there's still a lot of opportunities here, and maybe a little bit more shifted to research rather than production, although there are also some good production challenges. And one of the findings here is that actually UW system, in particular UW-Madison, UW-Milwaukee, have pretty strong efforts in these areas already because they are strong research areas. So there's probably some good opportunities for partnerships there with companies that want to get into it more. And although you would not maybe think of Wisconsin as a real leading state in terms of producing lithium-ion batteries, we do have a presence and components are being made, but a lot more can be done to integrate the supply chain and kind of make more of a closed cycle. And Junjie can talk about that more if you'd like. So again, here are some kind of highlighted areas, and I'll just talk briefly about recycling. As you make these lithium-ion batteries out of kind of sometimes exotic components or components that can have sometimes hazardous waste associated with them, of course, have to think about what happens at the end of their life cycle. And as these charts show, there's going to be a continued increase in both number of lithium-ion battery packs produced and also the total market for them. So being able to recycle is an important thing. And so without getting into too much of the technical detail here, Junjie identified kind of these two primary routes, pyrometallurgy, which is more of a, well, you literally kind of burn the organic components away and then try and recover the metallic components that you'd like to recycle, which is more kind of the traditional technique of getting these out. Downsides are that it takes relatively high energy consumption. There can be some pollution associated with it. So this alternative approach is hydrometallurgy. Here you use kind of an aqueous chemistry to leach the components that you want out using acids and then kind of subsequent concentration purification steps. That has some challenges with it too. And then the real kind of challenge here is you need to sort of complete the step then, and you'd like to recover these metallic components in sufficient purity that you can then reuse them back into actually making more lithium-ion batteries, right? When we think about recycling of other things like plastic water bottles or something, we often talk about downcycling, where you recycle the materials, but they come back to life in a maybe less interesting product, if you can say it that way. Really, to really make lithium-ion battery market stable, we'd like to have really a full closed loop here. And so there's a number of interesting kind of technical challenges to make that happen. Okay, then last sector here was biogas. And I don't know if everyone's kind of maybe fully appreciates kind of what happens when we talk about biogas. So all organic materials, as they break down, they decompose, they give off different products. If you can do that decomposition in an anaerobic environment, an environment without oxygen, then you can produce methane gas as one of your products. And so this sort of anaerobic digestion is a method to take everything from livestock waste, like manure, all the way to leftover crops and waste from crops, and even wastewater and food waste, and produce something useful out of it. So then this methane-based biogas can then be used for a variety of things. And then you also have out, you get kind of out also this digestate product, which can be used in fertilizer and a variety of things. Okay, so it's interesting process, and we do have some in Wisconsin, but there's a number of kind of policy barriers we found. So this part of the project was worked on by our UW-Oshkosh colleagues, Kevin Crawford, who's here on the call with us today, and then one of his colleagues. And what they found is that, you know, there are, it's not so much a matter here of, you know, we need a higher precision tooling or you know, some of these other more sort of traditional manufacturing challenges. In other words, the components of the digester are relatively straightforward. It's more kind of policy challenges and thinking through how do we sort of make the biogas product available to people. So there's a number of interesting challenges there. Like, for example, the biogas is not very transportable. It's hard to, if you do start to produce a large volume of the methane gas, it's not easy to just get it integrated into traditional natural gas delivery pipelines, for example. They're not everywhere you'd like them to be. It's not always easy to build and access the injection points. There's chemistry challenges, kind of all kinds of things. So as an example of a technology area that could help that is to think about additional products. So for example, we could take that methane, convert it to methanol, and this then makes a more usable product for the end user. Or make something that's more easily transportable and then maybe easier to sell. So they sort of talk through a number of interesting challenges and opportunities there for biogas. Okay, so before we open it up for questions or discussion, let me just mention the other thing we did in this report, in addition to kind of highlighting some technology areas, is we also just made a few kind of policy recommendations. So one of the things we learned, as I mentioned, for lithium-ion batteries, is there's actually a lot of capacity across the state at the UW system institutions where people are working on some of these things. And you know, one of the advantages of the comprehensive universities that we have is we are throughout the state, and so we have a little bit more of an ability to know what's happening with manufacturers in Western Wisconsin, in the Fox Valley, elsewhere, and so that sort of gives us a natural network of people that we'd like to maybe leverage a little bit better to try and connect manufacturers with some of these opportunities and help talk them through what steps might be to try and get integrated into those. So we could probably do a little bit more there. Also, we have these great resources, which are the campus research foundations. So of course, that's WRF at Madison, and UWM has a research foundation. And then in the comprehensives, we have WISIS. And they also already have a lot of these connections or know a lot of what's going on. And we feel like there's probably some ways that the Research Foundations can maybe incentivize some of those connections, and we can talk more about that if you'd like to. And then there already are a lot of policy groups that think through, what does solar energy need to thrive in the Midwest, those sort of things. But we could probably do more to kind of centralize, kind of map out, where are our existing manufacturer capabilities in a couple of these key areas, how they need to transition to green energy, and how can we get them connected back up. Okay, so those are a few of the things that we thought through from a policy point of view. And then just as I close here, let me just kind of explain what we're doing for the project now. So this funded project through the Thompson Center, which we're very grateful for, ended at the end of June here with the state fiscal year. But from the kind of point of view of the sort of Wisconsin idea and making ourselves available to manufacturers, we're sort of continuing with it in that we've sent out this report to a large number of manufacturers based on who we identified in the economic analysis as maybe being interested or have the right capabilities to participate in some of these areas. And so we've written this report with sort of example ideas in it. So we're now just trying to kind of make folks aware of some of these opportunities and start some discussion. And as Tom indicated, we've already heard some really positive feedback. I know I've had 5 or 6 phone calls already with different companies that want to talk further about this. Tom's had some conversations as well, maybe a few others too. And then the next step really then, what at least from our end here at UW-Eau Claire, what we're doing with it is I'm just kind of interviewing these companies, if you like, understanding their business needs, understanding what they see as their manufacturing capabilities, their competitive advantages, how they want to grow. And then we're sort of going back, not just to our examples list, but actually kind of, diving back into some of the research that we did and saying, okay, here's a little more targeted thing you might think about, and then can we think about a way to maybe get it funded or have you work on it. So that's kind of what we're hoping to do. And frankly, I think if we get a handful of those going, we would see it as a real success for the project. Okay, I think that's our half hour, so I should stop there. Again, we thank the Tommy Thompson Center for funding the work, WRF for hosting the seminar today. And then I really need to acknowledge a number of groups here. I apologize maybe for not listing all the individuals I had conversations with, but a number of statewide groups who do a lot of thinking about these topics, and we wanted to avoid just reinventing the wheel. So really grateful for all those conversations that helped us to kind of make sure we're doing something substantive here. So happy now to answer questions. I've got some email addresses there on the screen if you do want to contact Tom or I later, but let's open it up for discussion.
Great. Thank you so much, Matt and Tom. That was a great summary. I know I looked at the actual report you put out. Can people receive that report if they contact you at those email addresses if they're interested in seeing it?
Absolutely. So of course we have a PDF available, and yeah, we're happy to send it out to anybody that would like one.
Great, wonderful. So I'm going to start with a couple questions, and we're getting a few from the audience. Please do add your questions up there. We'll get to those in a second, and we want to be able to answer whatever anybody has here. And as Matt and Tom said, they have some of their collaborators. Dr. Junjie Niu and Dr. Kevin Crawford are both here too to address questions to their parts of the report. So to start with, I just wanted to say, working with UW-Madison, we have undergrads in our laboratories, but not necessarily given the playing such a large role in the research as we might have at some of the UW comprehensive campuses. So can you all talk about, I was impressed in reading the report on the involvement of undergrads in this. So can you talk a little bit about the undergrads' involvement in this report and how you're supplementing their education by being involved in something like this? What are they going to go on to do, and can they even play a role in bringing this, some of this manufacturing into Wisconsin?
Yeah, I think I'll throw that one to Tom. He's got a pretty mature research group and way he integrates the students. So do you want to take that, Tom?
Yeah, will do. Thanks, Matt. Yeah, so thanks for asking that question. I really appreciate it. So in the Department of Economics up here at UW-Eau Claire, we really pride ourselves on integrating our undergraduate students into a variety of research, and this project was no exception. I know Matt had students working with him. I had students working with him, as well as my economics co-author, Dr. Yan Lee, also had students working with her. And, we try to get those students involved right from the beginning, freshman, sophomore year, so that by the time that they, launch out into the outside world, they have real solid expectations about, what an economist does, what are the expectations are for us out in the real world. How do you report economic information to lay audiences? How do you gather economic information, so on and so forth. And it's really a joyful thing, frankly, as an instructor, to work with these very highly motivated students. Myself, I work with a group of between 4 and 12 students at any given time. Other people in my department work with some more, others some less, but it's a very important part of our program, and it's really one of the best parts of my job, frankly.
Yeah, and I'll just add to that. I think Tom kind of alluded to it, but a real key here is kind of scaffolding the projects for students. So we indeed try to get them in young, give them kind of bite-sized things to understand what they're good at, what they're passionate about, how they learn, and then it enables us to build sophistication into their research projects as they kind of go through their undergraduate career, and then they can do some pretty sophisticated things by the time they're seniors. And of course, as instructors, as faculty, that's always gratifying to see.
Great, thank you. Another question I have is the timing of this report coming out. I'm sure that when you started this project, you were not considering that we're going to be entering into a global pandemic and economic downturn and a lot of social reckoning with inequality and things like that. It's heartening to hear that you're hearing back from industry. Do you think Wisconsin manufacturing industry is more or less open to trying new ideas in this time, or doesn't it really matter?
Well, that's a great question, and Tom should also comment on this as well, but I'll just say, I think certainly some companies are looking very carefully at their supply chains and thinking about not just their supply chains, but also their clients, and saying, hey, do we need to think about expanding into some new areas? I think absolutely so. I don't think anyone is envisioning that globalization is going to go away, but certainly as both kind of geopolitical things like trade wars and also things like a global pandemic, there's certainly something you said for having more kind of local supply chains, or at least available vendors. So yeah, I do think it's something that they're thinking about. You want to add anything to that, Tom?
Yeah, I would concur with everything you just said, Matt. Personally, I think it's been very this project's been a very positive thing. My experience has been that our Wisconsin manufacturers are really keeping an eye out for what the next thing is. They're very interested to learn about what possibilities exist out there. And yeah, I don't know if anybody knows exactly what the future holds, but I think there's a lot of folks putting a lot of brain power into thinking about what the next step to all these problems we just mentioned are, whether it's global climate change or it's supply chain reorganization due to both political as well as health related events. So it's exciting. It's an exciting thing, right? It's an exciting thing.
Great that we can get some positivity out of it and look to the future, not just how we're dealing with what's happening right now. I appreciate that. We do have a question from the audience. Is there any work going on in the state, either in the universities or manufacturers, on methane gas to methanol conversion? And do any of you know any good contacts in that research work? I'm guessing you might have looked at some other possible areas within sustainability to see what might be explored. I know this wasn't one of your, well, maybe it's part of the biogas, I'm not sure. I'll just question there.
Yeah. Kevin, do you want to add anything there?
Yeah, so we started off talking about methane to methanol a few years ago. UW-Oshkosh has 2 biodigesters, and we had a 3rd one. And the electricity rate that we get once we are a large generator is just so small. It's almost anything is more valuable than the methane. So if you can turn that chemical into anything else, you probably have more value. And so we dabbled a little bit trying to find some inexpensive ways to turn methane into methanol. There's a number of catalysts that are published in the literature. We didn't feel that any of them were quite ready for commercialization. But currently we're working on another project. We have a company, not a Wisconsin company, but we have a company engaged with us looking at converting the methane and some of the carbon dioxide into liquid fuels. Their target is a diesel equivalent.
Thanks for that, and hopefully that answers the question. And the questioner wants to ask any follow-ups on that, please just go ahead and type them in. I have a question too that kind of leads to, kind of ties into that, and that some of these areas are higher risk and earlier than others are. I think you brought that out really well, Matt. You know, solar, we know what photovoltaic cells do, and you looked for some specific ancillary areas. Wind is also a bit advanced. There's always room for innovation. With the lithium-ion batteries, Junjie, I was wondering if you can talk to, are there different types of companies that are able to take on that extra level of risk? What do they need to make that worthwhile? And how do you encourage kind of more of that risk taking, especially in uncertain times?
So I think the lithium-ion battery, so the Wisconsin, we have a very good manufacturing, like the Johnson Control. Now they changed to Colorius, right? So this is one of the largest manufacturer for the car batteries. So now they also are doing some lithium-ion battery. And also we have a second largest customer for a lithium-ion battery, Milwaukee tool. So they generate a lot of cordless power tools. I think they use the lithium-ion battery, I mean, just a little bit less than ample in the world. I think that I have a very close collaboration with the Milwaukee tool. So they want to, you know, get the battery can be manufactured in the Wisconsin, so then they don't need a long transportation from Japan, from China. So now most of the battery, not more, I would say 100% of the battery, they are shipped from Hong Kong, from China. And also their technology is from Samsung, Panasonic. So I mean, so we don't have these manufacturers, so they pay a lot of money, extra money to this out of the US companies. I think I talked to them many times, and they want to get the supply chain, if they can within the Wisconsin, then they will largely reduce their cost. And for the Colorius, you know, they have manufacturing, but their materials. Actually, the US, we don't have a lot of electrode material manufacture, even in the US, not only in Wisconsin. So most of the material they generated in the Asia countries. So how we can do that? I think that the DOE, Department of Energy, they already realized this is very critical. And our President Donald Trump, they signed a document in 2018, I think. They said US has a very critical material need, including the lithium and the cobalt and the manganese. So this is the three of the very critical materials element in the batteries. So we need that because US don't have a lot of lithium, and especially the cobalt. We are largely needed that. And how we can make up this. So the DOE recently released a very big project. I think they put maybe $100 of million to want to improve the manufacturing or the recycling of this emergent element in the US. I think for this opportunity, I think a lithium battery manufacturer is a very good opportunity. So if we can improve the recycling of this element from the spent batteries, or we can generate some cheaper way to produce these materials, I think it's very helpful. And as for the Wisconsin, in the Midwest, actually we are very delayed to catch up this very important manufacturing in the lithium battery. Actually, in the US, like California and New England, some like Massachusetts, they already have several companies, startups, small companies, and even some bigger agencies. They already start to develop this lithium-ion battery manufacturer. I think it's a time for Wisconsin, if we can help to grow or establish this kind of lithium-ion battery manufacturer. I think this will be a very good opportunity, at least in the Midwest region, and even the national wide. I think it's very important.
Yeah, could I just interject there and just highlight 2 points that Junjie made? I think number one, in terms of managing risk, having those customers here is a big part of managing supply risk. So indeed, you can all win trivia night now by knowing that Apple is the #1 user of lithium-ion batteries, but then it's Milwaukee Tool, #2 behind it. So that's right here in local. And the other thing I think is because we have a relatively strong research profile at UW-Madison, at UW-Milwaukee, and a few other places, I think this allows some companies to maybe develop some partnerships that can help to manage and share that risk, and also to find funding opportunities that helps to manage that risk. So I think there are some things that can be done there. And then maybe not quite on the topic of the first question, but Junjie just makes a really critical point about the resources and the recycling. You know, when people talk about transitioning away from fossil fuels, a motivation sometimes given is for sort of geopolitical stability, or we don't want to be dependent on foreign sources of oil. But we have to be careful we don't just develop dependencies for, as he says, cobalt or lithium, or in the case of solar cells, it's indium, which is a not terribly abundant material and is needed to make transparent oxides for the solar cells. So some of these recycling technologies are not just economically important, but they really are important to making a sustainable supply chain in the long run for those technologies.
You both make really, really, really good points. And I love the idea of more local recycling. And just as a complete side note, because we're trying to bring all of Wisconsin into this, I know that Wisconsin's favorite quarterback, Aaron Rodgers, is very much about trying to recycle some of these rare earth metals and stuff in our electronics. So let's get him on board to promote this within the state so that we can have kind of a closed loop of what we're using and what we need. I think people might listen to him, which would be great.
Actually, sorry, I just want to cut in one more thing. Actually, I'm working with the Milwaukee Tool and the Colorist. So they have a bigger project in recycling batteries, lithium-ion batteries. So hopefully we can grow up. We have some prototyping recycling project, and then we want to move to the industry to scale up so we can recycle more batteries. So I hope they can do in the near future. Yeah.
And I think that's a great point too. All of these points kind of come to sustainability, and the green manufacturing economy is something that transcends your political view. I think, Tom, you were talking about this a little bit with climate change. I think no matter where you're coming from, it makes good economic sense as a state economy to get into this. I don't know if any of you can speak a little bit more to that on how you can have a broad appeal through all of this.
Yeah, maybe Tom has some thoughts, but I'll just repeat this anecdote I gave in the talk, which is, you know, building a solar farm right now is cheaper than just operating a coal-fired power plant in many cases, by which I mean there's the environmental case for solar, but there's also a strong economic case. It's not really a trade-off anymore. So when you see all these utilities around the state promising to go carbon-free by 2050 and other kind of pledges like that, they're doing that because they see the economic case for it now. So we are at a unique point, I think, or at this point where people have been trying to get to for decades with some of these clean technologies. We are really at the place where they can be deployed at scale, at least on an economic basis. Other challenges, of course, but there is a strong economic case now to be built.
Yeah, I would just concur with that. I would think, you know, speaking for myself personally, that the point is not really necessarily advocacy with any of this, but rather to convey information about what the economic trends are, what the changing cost structures look like, what likely supply changes what likely supply chain changes are coming down the road, and then to let Wisconsin businesses, you know, have that information, and then for them to understand how best for them to proceed. They're the ones who have the skin in the game. You know, it makes sense for them to be making those decisions. But there's certainly an important role to be played for information dissemination about the economics, as well as the emerging technologies in these areas.
Great, thank you. I guess one final question I have, and please, anyone else who has any questions, put them into the Q&A, is obviously you were looking at this within Wisconsin. We're all part of the University of Wisconsin system. There's taxpayer money within Wisconsin going to support the university, and the Thompson Center is looking at developing the Wisconsin economy. So do we have, who's our competition in this? Who do we have to, I don't want to say we're taking anything away from anybody else, but we've talked about globalization and some needs to get more of this manufacturing kind of back home for a lot of geopolitical reasons. Do you know of initiatives like this going on in other states as well? And are we better off combining with them, or how does this all work out?
I think that's a very, very big question. So one slice of that is there are some very large, and in the case of wind and solar, some pretty mature consortia which are trying to pool resources. You know, think about this as a national issue. I think one of the reasons that we focused kind of on the supply chain side is, you know, that there are big competitions, big efforts at all the big research universities to develop the new breakthrough technology, et cetera. But I think what we would like, the sort of selfish piece of this is we would just like to see Wisconsin take, you know, because we already have these big advantages in manufacturing that have made us a manufacturing powerhouse in the country. Can we just leverage those same competitive advantages and just integrate better into some of these supply chains? So I think to a certain extent, a rising tide does lift all boats here. As the technology matures, it's going to benefit certainly the country and the whole globe. But yeah, we would just like to see Wisconsin companies more integrated into more of these supply chains. Does anybody want to add anything to that or say more about other competitors, or as Jennifer was alluding to?
I just want to add for the battery recycling part. Our competitor, I think, actually not too many states they are doing this. I mean, in a large scale, they're the center, NSF sponsored center in Massachusetts. So they are doing some battery recycling for several years. And Argonne National Lab, they just get this funded by the DOE, Department of Energy. They're the recycling center. So they will start, I think they will just start from last year. I think they get a bigger funding from the DOE. So they call it resale. They call it resale. I attended several meetings them, and I went to the Argonne. And that's maybe the one. But if we start now, I don't think it will be very late behind them. So we can catch up. And another state like in Minnesota or the other I didn't hear anything about that. Maybe we are not very behind most of the states. Yeah.
That's great, thanks. And I think you know, that was a little bit tongue in cheek about competitors, but I think I love that you concentrated on where we have strengths already and how we can leverage those strengths and what we as a state are uniquely positioned to move into, and to, you know, get some components elsewhere from our neighboring states or states across the country, and we can concentrate on some of the things we're doing here. I think it's all good for the national economy along the way. So I'm not seeing any other questions from the audience right now. Is there anything else any of you want to say before we close up here?
Just that for myself, I was excited to do this because for me, this is exactly the sort of thing that we at UW Systems should be involved in. As I said, the comprehensives were across the state. This is a great opportunity for us to take what we understand about the different regions of the state and say, you know, how can we provide a resource that's going to help move the state forward? So I think it's a great collaboration. It's a great topic for the Thompson Center to put out there. And so I think we're all really happy to be able to work on it together.
Great. I think that's oh, go ahead, Tom.
Just quickly, yeah, I would also encourage anybody listening to this that thinks like, oh my gosh, you know, could these guys figure this thing out for me, or you know, this is something I'm interested in. Please, you know, do reach out. As I mentioned, you know, we're always working on a variety of projects for a variety of entities in my department, and I know other departments at UW-Eau Claire too. It's not to say that we can address everything, but yeah, you know, this kind of work is well, I'll be honest, it's a lot of fun to do, and I think it really enriches the state as well as our programs. So.
I think those are great ways to end this. I think you guys really do exemplify the Wisconsin idea, and I love that this opportunity was put out there and supported for you, and I love that you're going to continue working on and talking to manufacturers, and I'm going to be watching to see where this goes in the future. It's a wonderful example of a really pragmatic collaboration that can make a difference within our states. So I know we can't clap for you, unfortunately, and I'd say to everybody when we do this in person, it's a very informal gathering. We have beer and wine before things start so that we can really have a discussion. So I hope that someday when we're back together again in person, we can have more of that. But this has been a really, really good discussion, and I'm sure I'm joining everybody who's listening and those who will listen to the recording in the future in thanking you so much for doing this great work and for sharing it with us. So thanks so much.
Thanks, Jennifer. We enjoyed it.
Thank you for the opportunity, Jennifer. Thank you.